So in this video we'll be talking about the structures in Rust. So Rust does not have object oriented programming. In object oriented programming we create a classes, so the classes define some blueprint. Suppose let's take an example of class car. We define some properties and methods for that car. So every car will have four tires, so we can have number of tires as a property, and engine and doors and glasses, etc. And car can have functions or methods like starting, uh, uh, increasing the speed, decreasing the speed, and changing gear and stopping, etc. So these are the methods of the car, and from this class car we can create a objects. So these objects are the real values. Suppose from car we can derive an object called Ferrari, and we can also create another object like Lamborghini, etc. So we can create the these all of these Lamborghini, Ferrari cars from the class car. So car is like a blueprint, and you can derive any car you want by inheriting that class and implementing your own code. So that is the object oriented programming. In Rust we do not have that, so the close thing we get to the object oriented programming in Rust is the structures. So in this video we'll be talking about the structures. So the structure is a grouping of an object. So we can say struct, let's say student. So for this student we have some properties, right? So student can have name, so the name is of type string, and student can also have age, right? So age can be unsigned integer, and student can also have the year of education. So like if the student is first year, second year, or third year, or fourth year. And also student have some mark list. So in this mark list we can define this as a array of 5. So we have 5 subjects, and all the marks of those subjects are stored in an array. So these are the student properties. So you can see you can group the properties of any object into that name. So student, so whenever you refer to the student structure, that means that student have all of these properties: name, age, year of education, and mark list. So now let's see how you can initiate all these values. So let's say let s1 is equals to, that is the student one, and you can say student and do the open brace and close brace. So inside these braces you can define the values for this student. So the name can be text69 dot to string, comma, and I can say age. So age is let's say 21, and year of education is 4, so he's studying the 4th year, and mark list is, let's say 10, 20, 30, 40, 50. Now you can see there are no errors. If I go and delete one of the value, I will get an error because we have fixed length of 5. Now here we have the student 1 s1. So I want to print all the values of the student structure, so I can do this using s1. When I run this I will get an error because of the debug trait. So you cannot print directly the structure, you need to do the derive. So we need to use the debug feature or attribute, so that we can print all of the members of the student. So let's run this, and you can see all the members of this student s1. So that is how you do the debug. And let's also create another object, let s2 is equals to student, and you can say name is equals to, so if you want to copy the remaining contents of s1, you can say dot dot s1. comma dot dot s1. So what this means is we are giving the name YouTuber and remaining fields must be imported from s1. So the remaining s1 values will be copied into the s2. So let's copy this and let's run this one, and we should see the two students with only the name difference. So you can copy multiple values like this as well. So for now I'm going to change this year of education 1 and mark list. Now this you can see here I have declared this as a string, not as a string size, because if I declare this one as a string size, we don't know whether the string will get dropped first or the structure get dropped first. So that's why it is better to declare the strings as a string data type. Now let's declare another function test, and this is going to take the student structure. Now similar way, if I go and say student, now we got an error stating that the student structure is not public. So let's do the public. Now if I say test of s1, you will get the error because the value has been moved. So that's why what we are going to do is we are going to say ampersand student, so that the reference of the structure will be passed. So this is the basic of structures, and the next one we are going to talk are the implementations. So you can implement a function to the structure. Suppose I want to calculate all the sum of all the mark list for the student. So what I can do is I can say impl implement student. So here in this block of code I can write different functions, and all those functions are called associated functions that are associated with the student structure. So let's say function total marks, and this will take the parameter as ampersand self. So here the ampersand self is referring to this structure. So now I can access the members of this one as a self.ah. So we can also print the values here. So print s1.name and print s2.ah. So you can access the inner members of the structure object using the dot operator. So let's run this one, and we should see the both values. Now let's come into this implementation of total marks function. You can see ampersand self. So if I remove this self, so what will happen is this function will consume this structure object. So when I call s1.totalmarks, from the next line of code the s1 will not be valid because the total marks function has been consumed. So that's why we are going to say ampersand self. So now let's go and add this one. So let mute counter is equals to 0, and for I in 0 dot dot self dot mark list dot length, and counter plus is equals to self dot mark list of I. So we are adding to the variable counter, and we can return counter. So return u32. So this should be fine. Now I want to calculate the total marks of all these mark list for the student s1. So I can say s1 dot total marks. So that's it. So I should get the answer 30, 60, 100, 150, right? So we can see the answer 150, and you can also modify these values. So here we can see the ampersand self, right? So you can also do ampersand mutable self, so you can modify these values. So what we are going to do is, for each and every value I want to add 100 marks. So I want to increment each and every mark with 100 marks. S1 is mutable, so let's declare this S1 as mutable. Now after the executing the total marks function, each mark will be added by 100, incremented by 100. So let's run this, and we should see the marks 10 changed to 110 and 20 changed to 120 and so on. Each mark has been updated, incremented by 100. So that's how you can change the members of the structure using the mutable reference. And another thing is the constructors. In object oriented language you can declare a constructor. So this constructor will take same name as a class name in the object oriented programming. So you can declare the default values or some initializing values whenever you declare an object, but here the constructor can be of any name. So the one standard rule in the Rust everyone follows is the using the new function. So function new, and this will return of type self. So what this means is we are going to create an object and we are returning that one. So how you wanna create this? So remember like this, self, capital self in the means this student. So instead of I'm going to create student, I want to create self. Now you can see after I hit enter, the editor has been auto filled with the members of the structure. Now I can give the default names. So default name is null. So the default age for anyone to do the graduation is 18, and the year of education by default is 1, and mark list is 0 0 0 0 comma 0. You can cast this as U32 5 as well. So we have declared a new implementation of the structure. So whenever this function is called, then we will get a object with these values. So let's go and do this one. Let's comment out. Now to use these using the student new, so you need to use double colon to access the implementation from the structure point of view. Let s3 is equals to. Now if I go and print the s3, so let's run this, and we will have the default values we have been given. So you have seen this new, right? In the vector videos we have declared a vec colon colon new, so that will define a null pointer and the null capacity and null length. So it is like a basic one. And another thing is you can also compare the students, whether which student has got the more marks. So if say is greater, so the first we are going to take parameters as two student objects. So first one is self and the next one is s2, that is also a student reference. So we have two student objects, s1 and self and s2. We are going to calculate all of these marks. So self dot total marks So what we are going to do is, if self dot total marks greater than s2 dot total marks, then we are going to return self dot name. Okay, so self dot name dot clone. So here we can see we are trying to return a string type, because if we return that one, you will get null here. So these are the string data types that are stored on the heap. So if you pass the value into any function, these will become invalid. So what we are going to do is, we are going to implement another trait called clone. So this will allow us to clone the structure and the members as well. So return type is string, and else return s2 dot name dot clone. Okay, so what we're going to do is remove this one, simply say return s2 dot name dot clone. Now we are good to go. Now let's go and compare these s1 and s2 students. Of course, by seeing s2 student have greater marks than s1, so let's go and print that out. S1 dot is greater of s2. Now let's go and print this. Now we should see the name YouTuber on the console output, and we can see we got the name. So this is how you can do structures and implementations. You can also declare a vector. Let mute you can, let's say I'm going to store all of the student objects into one variable, so we can use vector for that. So vector of type student. So since I want to store the student structure objects, I want to declare a vector of type students. Now we are going to say vec new. Now I can push all of these objects into my students, and students dot push of s1, and we can say clone here. Otherwise we are going to since we are accessing past this line of code, we need that value, so that's why we are cloning and pushing. So copy this and paste here, change this to s2. Now you can print this, the students vector. So now we can see the both students have been added to the vector. So that's all about the structures and implementations in Rust.